Hello everyone, I'm Dr. Shaik Ruksana Begam, working as Assistant Professor in the Department of Electrical and Electronics Engineering from Institute of Aeronautical Engineering, Hyderabad. Today I am here to deliver a lecture on Kirchhoff laws and equivalent resistance calculation. Before going for the topic, in the previous lecture we have discussed about the basic elements and Ohm's law. So basic elements are the foundations to build an electrical circuits. Basic elements are basically of two types. One is of active elements, another one will be of passive elements. So active elements are nothing but which delivers energy to the passive elements. So passive elements are opposite to the active elements which absorbs energy. The examples of active elements will be of voltmeter, ammeter, power and semiconductor devices. Coming to the passive elements are nothing but it will absorb energy. The examples of the passive elements will be of resistors, capacitors, and inductors. Coming to the Ohm's law was discovered by a German scientist named George Simon Ohm, who discovered Ohm's law in the year 1824. He discovered Ohm's law to know the relationship between voltages, currents, and resistance in a circuit. So basically, the formula of Ohm's law will be denoted with V is equals to IR. Okay, moving to the today's topic. Today's topic is of Kirchhoff laws. Kirchhoff laws are invented by a German scientist named Gustav Kirchhoff in the year 1845. Is a German scientist named Gustav Kirchhoff. He discovered Kirchhoff law in the year 1845. So this Kirchhoff laws are discovered to know the Kirchhoff laws are discovered to know how currents flow through a circuit and how voltages varies around a loop in a circuit. So these Kirchhoff laws are of two types. First one is Kirchhoff current law, another one is Kirchhoff voltage law. This Kirchhoff currents law works on the principle of conservation of charge. And the Kirchhoff voltage law will work on the principle of conservation of energy. First, we need to know what is conservation of charge in Kirchhoff current law and what is conservation of energy in Kirchhoff voltage. Moving to the Kirchhoff current law, it works based on the principle of conservation of charge. Conservation of charge is nothing but a total amount of charge flowing into a node must be equal to the total amount of charge flowing out of the node. It denotes whatever the current entering into the junction must be equal to the currents entering out of the junction. So the Kirchhoff law statement is written as Kirchhoff current law states that the total current entering into the junction or a node in an electrical circuit is equal to the total current leaving the junction. So here it can be written as currents should be equals to currents leaving. So if you see this circuit, here it is a junction where I1, I2, I3 are incoming currents and I5, I4 are outgoing currents. So here it can be written as I1 plus I2 plus I3 is equals to I4 plus I5. So the total currents entering into the junction should be equal to the total currents leaving the junction. So from the previous circuit, we can see that the currents entering plus current leaving should be equal to 0. So the currents entering in that circuits are I1, I2, I3 and the leaving are I4 and I5. It is denoted with 3 plus 4 plus 5 is equals to 6 plus 6, which is taken as minus 12 plus 12, which is equals to 0. If we take one example to solve the Kirchhoff current law, here What is the example problem? At a junction, three currents meet. Here is a junction which is having three currents. So, which is I1, which is entering into the junction, taken as 4 amperes. I2, which is leaving out of the junction, which is taken as 3 amperes. And we have to find the I3, which is leaving out of the junction. So already we know sum of incoming current should be equal to sum of outgoing currents. So here the incoming currents are I1. The outgoing currents will be of I2 plus I3. So the value of I1 is given, which is taken as 4 amperes, and I2 is given, which is of 3 amperes. Plus we have to find I3. From I1 and I2 we can find I3 as I3 is equals to 4 minus 3, which is taken as 1 ampere. So the amount of current leaving out of the junction, which is I3 denoted as I3, will be equal to 1 ampere. In this way, we have to calculate the incoming and outgoing currents. First, we have to know which are the currents coming into the junction and which are the currents leaving out of the junction. For example, we'll solve the other problem. To know more about Kirchhoff current law, we'll solve another problem which is taken as in a circuit node. The currents are as follows, which is I1 is taken as 5 amperes, which is entering. I2 is taken as 2 amperes, which is leaving. I3 is taken as 4 amperes, which is also leaving. And I4 is taken as entering. So here if we see, for a node, 4 elements are connected, which are denoted with I1, which is entering, I2, which is leaving, I3, which is also leaving, and I4, which is entering. So the values of I1, I2, I3 are given. We need to find I4. So basically we all know the incoming current should be equal to the outgoing currents. Here I1 is given, which is entering, I1 and I4 are entering, which is equals to I2 plus I3. So we already know the values of I1, I2, I3. From that we can calculate I4. So first I1 is given as 5 amperes plus I4, and 4 plus 2, which is equals to 6, 5 I4. So from this I4 is equals to 6 minus 5, which is nothing but I4 is taken as 1 ampere. So the value of I4 is taken as 1 ampere, which is entering into the junction. The other example will be consider a node where the currents are as follows, which is I1 is of 6 amperes, which is entering into the junction. I2 is of 2 amperes, which is also entering into the junction. I3 is leaving and I4 is also leaving, and the I4 value is taken as 5 amperes. Here I1 value is given, I2 value is given, I4 value is given. We need to find the value of I3. Here for a node, if four elements are connected, first I1 is taken as entering, then I2 is also taken as entering, I3 is leaving out of the junction, and I4 is also leaving out of the junction. So I1 is taken as 6 amperes, I2 is 2 amperes, I3 is, we have to find I3, and I4 is taken as 5 amperes. As per the Kirchhoff currents law, we know that sum of incoming currents will be equal to sum of outgoing currents. So here the incoming currents will be of I1 plus I2, and the outgoing currents will be of I3 plus I4. So we already know the values of I1, I2 and I4. We need to calculate the value of I3. So I3 first, what is the value of I1? It will be of 6 amperes plus I2 is 2 amperes. I3 we need to calculate plus 5 amperes. 8 is equals to I3 plus 5, where I3 is equals to 8 minus 5, which is taken as 3 amperes. So the value of I3 which is leaving out of the junction, the value of I3 will be 3 amperes. In this way, we need to calculate the currents which are entering into the junction and which are leaving out of the junction. So the Kirchhoff currents law states that sum of currents entering into the junction will be equal to the currents leaving out. In this way, we need to calculate the currents by using Kirchhoff currents law. So Kirchhoff currents law is nothing but the amount of current entering into the junction will be equal to the current. So in this way, we need to calculate the currents by using Kirchhoff currents law. Kirchhoff currents law states that the sum of amount of currents entering into the junction is equal to the amount of currents leaving out of the junction. So here we have seen how to calculate the currents by using Kirchhoff currents law. In the next topic, we'll be seeing about the Kirchhoff voltage law. Kirchhoff voltage law is nothing but it works based on the principle of conservation of energy. First, what is conservation of energy means? This means that the total energy gained by a charge in a closed loop must be equal to the Kirchhoff voltage law works based on the principle of conservation of energy. The principle of conservation of energy states that this means the total energy gained by a charge in a closed loop must be equal to the total energy lost. That means the sum of voltages will be equals to 0. The statement of Kirchhoff voltage law is stated as the algebraic sum of all branch voltages around any closed loop of a network is 0 at all instants of time. That means sum of voltages will be equals to 0. And then it can also be stated as Kirchhoff voltage law states that the sum of all electrical potential differences, which is also called as voltages around any closed loop or a mesh in a circuit, is 0. It can be simply stated as the amount of energy across each element in a circuit will be equals to 0. So here is the example circuit to solve Kirchhoff voltage law. Here a source is connected which is taken as V, and the three resistances are connected in series which is of V1 plus V2 plus V3. So the Kirchhoff voltage law states that the voltages across each element or each of the potential. The Kirchhoff voltage law states that the potential difference across each element should be equals to the sum of voltage. So here the Kirchhoff law states that the sum of potential differences across each element means here the elements are V1, V2 and V3. The potential difference across each element should be equal to 0, which can be written as V1 plus V2 plus V3 minus V is equals to 0. So it can be written as V1 plus V2 plus V3 minus V is equals to 0, or in terms of voltage drops and voltage rise, it can be written as V1 plus V2 plus V3 is equals to 0. So to understand the Kirchhoff voltage law more, we'll solve one problem on Kirchhoff voltage law. Here is one example problem. The problem is consider a series circuit with a 12 volts battery and two resistors R1 4 ohms and R2 is of 6 ohms. Find the voltage drop across each resistor. So these two resistances R1 and R2 are connected in series, and a source is connected which is of 12 volts, which is taken as V, and here R1 is of 4 ohms, R2 is of 6 ohms. So before calculating the voltage drop across each resistance, first we need to sum these two resistances which are connected in series. So R equivalent we need to find, which is equals to R1 plus R2. The value of R1 is taken as 4 ohms and the value of R2 is taken as 6 ohms. The R equivalent will be of 10 ohms. After finding the R equivalent, we need to calculate current. So I is equals to V by R. We already know R, we got 10 ohms, which is taken from the formula V is equals to IR. From this we need to calculate the current. So I have taken as I is equals to V by R. So the voltage is given as 12 volts and the resistance is of 10 volts. Sorry, 10 ohms. Amount of current flowing is 1.2 amperes. So from this, we need to calculate the voltage drop across each resistor. So each resistor in the sense, so here the two resistors are connected in series. We need to calculate the voltage drop across each resistor, which is taken as V1 and V2. So already we know the value of I is equals to 1.2 amperes. From Ohm's law equation, which is equals V is equals to IR, we need to calculate the voltage drop across resistor 1 and voltage drop across resistor 2. So V is equals to IR. The value of I is taken as 1.2 amperes and the resistance at first element will be of 4 ohms. And to calculate the voltage drop across V2, first we have to take the current as 1.2 amperes and the resistance across the element 2 will be of 6 ohms. From this we can calculate V1 and V2, which we got is of 4.8 volts and 1.2 into 4 is of 4.8 volts and V2 is 7.2. Now, as per the Kirchhoff voltage law, we know that V is equals to V1 plus V2 or V1 plus V2 should minus V should be equals to 0. So here we got 4.8 plus 7.2, which is taken as 12 volts. The supply voltage is also taken as 12. 12 minus 12 will be equals to 0. Here we proved that the Kirchhoff voltage law, the sum of potential drop across each resistances will be equals to 0. In this way, we need to calculate voltages with the help of Kirchhoff voltage. We are moving to the next topic, equivalent resistance calculation. Why we are using equivalent resistance calculation? So the purpose of equivalent resistance calculation is to simplify complex circuit and analyze their behavior more easily. In the upcoming topics, we'll be having very complex circuit which consists of n number of resistors. From that, we need to calculate the currents and voltages. To simplify those complex circuit, we are using equivalent resistance calculations. The equivalent resistance of a circuit depends on how the resistors are connected in the way. So, equivalent resistance of a circuit depends on how the resistors are connected. The types of resistors, the ways, the equivalent resistance of a circuit depends on how the resistors are connected. The ways of resistor, how the resistors are connected are of three ways. First is of series connection, second one is of parallel connection, and third one will be of series parallel connection. Remember, in series connection, the current will divide and the voltage will be. Remember, in the series connection, the current is constant and voltage will divide across each element. For example, series connection is taken as n number of resistors will be connected in series. Series connection is nothing but the output of the first resistor will be connected to the input of the second resistor. In this way, series resistances are connected. Here, the current flowing in the circuit will be constant and the voltage across each element will differ. In the same way, for the parallel connection, the output sorry the input of in the same way for the parallel connection, the input of the first resistance will be connected to the input of the second resistance. In this, the voltage will be constant and the current will divide. We have to remember these 2 points. First thing, in the series connection, current will be constant. So in the series connection, current is constant, voltage is dividing. In the parallel connection, voltage is constant, current is dividing. In the series parallel connection, depending upon the connections, the current and voltage both will divide. So we'll move to the first series connection. How the resistances are connected in series connection means. So series connection is nothing but the output of the first resistor will be connected to the input of the second resistor. See, this is the example circuit. So the output of the first resistor is connected to the output of, here are the four resistors, or it can be taken as, so moving to the first connection. First connection will be of series connection. In series connection, the output of the first resistor will be connected to the input of the second resistor. In this way, we can take n number of resistors. So the first resistor will be denoted with R1, R2, R3, R4 and Rn. N number of resistors can be connected in series, and the output of the first resistor will be connected to the input of the second resistance. In the same way, the output of the second resistance will be connected to the third resistance. Here the equivalent resistance can be calculated as R equivalent is equals to R1 plus R2 plus R3 and so on till Rn. So here I have already told, in the series resistance, the current will be constant and the voltage across each element will be getting divided. So the current flowing through the circuit will be same and the voltages across each element will be different. In the same way, coming to the next one, it is of parallel connection. I have already told, in the parallel connection, the first terminal of a first resistor will be connected to the, moving to the next one will be of parallel connection. In the parallel connection, the input of the first resistor will be connected to the input of the second resistor. The circuit can be drawn as, in this way it can be denoted as R1, R2, R3 and so on till Rn. So here if we see, the input of the first resistance is connected to the input of the second resistance, and the input of the second resistance will be connected to the input of the third resistance. That means this resistors are all connected in parallel. Okay, in the parallel connection, I already said that the currents will divide and the potential differences across each element will be same. Here the current is dividing and it can be denoted as I1. Here also current is dividing, it can be denoted with I2, I3 until IN. So when these resistors are connected in parallel, the equivalent resistance can be calculated as R1 by R equivalent is equals to 1 by R1 plus 1 by R2 plus 1 by R3. If n number of resistors are connected in parallel, then it can be taken by 1 by Rn. So this, if only two resistances are connected in parallel, So in this way the resistance can be calculated, which is taken as R1 and R2. The R equivalent will be of R1 into R2 by R1 plus R2. In this way, we can calculate the resistances when they are connected in parallel connection. And moving to the next, combination of series and parallel. So here are few points we need to follow when the resistances are connected in combination of series and parallel. First thing, for complex circuit, simplify step-by-step procedure. See, first point will be identify the series and parallel groups. First, if we take one example, here are two resistors connected in series and two resistors will be connected in parallel. So for this circuit now we need, so it can be denoted as R1, R2, R3, R4. So for this circuit, we need to calculate the equivalent resistance. For calculating the equivalent resistance for such type of circuits, we need to follow few points. The first point will be identify series and parallel groups. Here are two series groups and two resistors are connected in parallel. So reduce the parallel resistors first. First, we need to reduce these two parallel resistors. I have already mentioned in the previous slide, when the two resistors are connected in parallel, we have to calculate in this way, which is R3 into R4 by R3 plus R4. Now, after reducing this circuit, we will get a value which will be taken as R5. So, from this circuit, if we reduce this circuit, it can be drawn as three resistances will be connecting in series, which is taken as R1, R2. After reducing this circuit, we will be getting R5. So, these three resistances are connected in series. So first what we have to do, identify the series parallel groups and reduce the parallel resistors first and add the series resistance. We have completed the step 2. We have to now add the series resistances which are of R1, R2 and R5. So to find out the R equivalent, we need to sum these three resistances which are of equals to R equivalent is equals to R1 plus R2 plus R5. From this we'll get R equivalent circuit. Repeat it until you get a single equivalent resistance. By adding these three resistances, I'll get R equivalent which will be of R6. So in this way we have to calculate the resistances when they are connected in series, parallel and combination of series and parallel. So in the next section, we'll solve more problems on series, parallel and series parallel resistances. So in this way, we have to calculate the total resistances by using series, parallel and combination of series parallel circuits. In the next session, we'll be solving more problems on series, parallel and combination of series parallel circuits. So in this session, we have discussed about Kirchhoff laws and calculation of equivalent resistances. First, why we are using Kirchhoff laws means we need to know the voltages and currents in the circuit. The Kirchhoff laws are basically classified into two types. One is of Kirchhoff current law, another one will be of Kirchhoff voltage law. Kirchhoff current law is nothing but the sum of voltage. Kirchhoff current law is nothing but the sum of currents entering into the junction should be equal to the sum of currents leaving out of the junction. In the same way, to calculate the voltages, we'll be using Kirchhoff voltage law, which works on the principle of conservation of energy, which states that the potential difference across each element should be equal to 0. The sum of the potential difference across each resistance or each element will be equals to 0. Moving to the equivalent resistance calculation, we'll be having three types of resistance calculations. One is of series, second one will be of parallel, and third one will be of combination of series and parallel. So in the next video we'll be dealing with the more problems on series parallel and combination of series parallel circuits. So yeah, that's it for today. We'll meet in the next section. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.